Okay, so let's look at a discrete probability example. So let's say you flip a coin 2 times. Within this experiment, there are 4 possible outcomes. So you could have heads, heads, you could have heads, tails, you could have tails, heads, or you could have tails, tails. Now, let the random x represent the number of heads that result from that experiment. And that x can only take on 0, 1, or 2 as a value, so it is a discrete random variable. Okay, I'll say it again. Because it can only take on a 0 or 1 or a 2, that makes it a discrete random variable. Now, let's look at it this way. So if you have number of heads and you have probability, okay, so the number of heads can either only be 0, 1, or 2. So the probability of getting a 0 is 0.25, the probability of getting a 1, and the probability of getting a 2. This table represents a discrete probability distribution because it relates to each value of a discrete random variable with its probability of occurrence. Now you can also do this with a continuous. So if a random variable is a continuous variable, the probability distribution is therefore called continuous probability distribution. A continuous probability distribution differs from a discrete probability distribution in a few ways. One, the probability that a continuous random variable will assume a particular value is 0. 2, as a result, continuous probability distribution cannot be expressed in a tabular form. And 3, instead of an equation or formula, instead an equation or formula is used to describe a continuous probability distribution. Okay, so I won't go into details of what that looks like, but at least you have an idea. This is an idea of what discrete random variables are, again, and how it works in a discrete probability distribution. All right. So another area for muddiest points was conditional probability. Essentially, what I want you to understand is that all events are not independent. Dependent events can be affected by an event that previously took place. Looking at the probability of one event due to another already have taken place is conditional probability. That's really what I want you to understand. Yes, there is a long way to calculate it using trees, but that's essentially what it is. And then, oh, I did provide an example. So an example, without going into the math, is let's say you are an OT in stroke rehabilitation looking at frequency of occurrences for a type of stroke. You have a male patient with severe ischemic stroke given poor prognosis, and you want to know what is the probability of the patient being male, given the information of a patient, and having severe ischemic stroke and a poor prognosis. What is the probability of these variables occurring together? And this is an example how an event can take place due to another event already have taken place. Again, I'm not going to go into the math, but that's essentially what it is. Conditional probability is the probability of one event happening due to another already have taken place. And the theory that we talked about, Bayes, essentially goes along with helping to understand conditional probability. And there's no easy way to explain this via reading. So I will provide a video to kind of walk you through it. but that's optional. I'm not going to give you a problem on this. I'm just simply showing you that there are different types of probability out there and that we use. Another area was causation and association. Now, we will talk more about this as we go because next week I'm going to give you a problem set looking at regression, and it'll go on a little more about causation and association. So essentially, association is correlation, okay? Looking at relationship, which can be positive or negative. Statistical tests, or we use statistical tests like regression, or like using regression like multiple regression, that will help us separate effective variables from one another. Causation is opposite. Causation is changes in a variable measured directly causing changes in another. Again, I'm going to go into this more next week, but this hopefully just to add it into the recap because it was one of the questions that we're still pondering. Okay. Last but not least, regression was mentioned. I'm simply adding it in here because I want you to know I did not forget about it. I am going to add this to next week because I want to give you a problem, but I already have a few set of problems that you will get this week, and I don't want it to be overbearing as it already can feel sometimes, okay? So just know regression models are coming.